Welcome. In this session, we are going to discuss about the properties of Laplace transforms. Properties of Laplace transforms help us to calculate the Laplace transform of more difficult functions. And we are going to discuss three properties. So we have the linearity property, shift property, and the final value theorem. So let's start the discussion. So the first, let's list the properties. So the properties include one, we have the linearity property. Number two, we have what we call the shift theorem or shift property, shift theorems. And then number three, we have what we call the final value theorem. So majorly, the discussion of these three properties is because of their significance in helping us reduce the problem of finding Laplace transforms on difficult functions. So first property, the linearity property. So let's see the statement. So linearity property says that if we have two functions g and f, so let f of t and g of t be any two functions whose Laplace transforms exists for some s greater than alpha, and let's see their constant. So then we have one, that the Laplace transform of f of t plus g of t is the same as Laplace transform of f of t plus Laplace transform of g of t. And then two, the Laplace transform of a constant c times the function f of t is the same as c times Laplace transform of the function f of t. So let's give the proof of these two properties of linearity. So Laplace transform, the first one, of f of t plus g of t is given by, from definition, integral from 0 to infinity e raised power minus st times f of t plus g of t, and then dt. And this is the same as multiply through by e raised power minus st e raised power minus st times f of t plus e raised power minus st g of t and then dt. Now when you supply the integral sign on each of the terms, we'll have 0 to infinity e raised power minus st f of t dt plus integral from 0 to infinity e raised power minus st g of t dt. And you see this is the definition of Laplace transform of f of t, and this is the definition of Laplace transform of g of t. So therefore, the Laplace transform of sum of two functions f and g is the same as the sum of their Laplace transforms. So that's the way we prove the first case of linearity. And the second case of linearity will be given by, so Laplace transform of c times f of t by definition would be the integral from 0 to infinity c times, e raised power minus st times c f of t dt so I have e raised power minus st times c of t, c times f of t. Then below this a constant, we can write this one as c integral 0 to infinity e raised power minus st and then times f of t dt. Now you see this is the definition. This part is the definition of Laplace transform of f of t. So this will be c Laplace transform of f of t. So therefore, the Laplace transform of c times f of t is the same as c times Laplace transform of f of t. That's how we prove the second case of linearity. So we could do an example to illustrate how we apply this property. Example, find the Laplace transform of the following functions. So A, 3 plus 2t, and B, 5t squared minus 2 e raised power t. So solution, for A, we'll say Laplace transform of 3 plus 2t is the same as Laplace transform of the function 3 plus Laplace transform of the function 2t. So using the first case of linearity, and you see this, we can write it as 3 times 1 plus Laplace transform of 2t, or 2 times t, which you can write now. Your second case of linearity, you can write 3 Laplace transform of the function 1 plus 2 Laplace transform of t. And from the Laplace transform tables, Laplace transform of 1 is 1 over s, so it'll be 3 times 1 over s plus 2 Laplace transform of t from the Laplace transform tables is 1 over s squared. Then if you work out this, you get 3 over s plus 2 over s squared. So therefore, the Laplace transform of 3 plus 2t is given by 3 over s plus 2 over s squared. And then the second case, or the second problem, part B, we have the Laplace transform of 5t squared minus 2 e raised power t will be given by Laplace transform of 5t squared, and then plus Laplace transform of minus 2 e raised power t. So which is the same as 5 Laplace transform of t squared minus 2 Laplace transform of e raised power t. Now you can work out this one from definition or use Laplace transform tables, and Laplace transform of t squared, you will get the answer to be 2 over s power 3. Laplace transform of e raised power t is given by 1 over s minus a.